Okay, think about this for a second. What if I told you your phone, like, really knows you, maybe even better than your best friend?
It's a startling thought, isn't it?
It is. Or that machines, right now,
Yeah.
today, can paint like Picasso, compose music that sounds, well, pretty convincing, and even spot diseases in x-rays, sometimes with accuracy that surpasses human experts.
Yeah, it definitely sounds like something straight out of science fiction. Almost.
Exactly. So, welcome to the deep dive. Today, we're embarking on this journey into the world of artificial intelligence, AI.
Hmm.
Our mission today is pretty clear. We're going to cut through all the buzzwords, the hype, the jargon. We've sifted through the sources you sent us, and we're pulling out the most important
The
bits.
key takeaways.
Yes. We really want to help you understand what AI actually is, how it works, where it's potentially going, and maybe most importantly, how it's impacting you right now in your daily life.
And your future,
Yeah.
absolutely. We're going beyond just definitions.
We are getting to the core of it.
That's spot on. The goal isn't just to, list definitions. It's about giving you a real kind of deeper understanding, its relevance, its implications,
Yeah.
both personally and, well, globally.
Right. Connecting the dots.
Exactly. Connecting the dots between the concepts, the latest trends, and what you actually see and use every day. We'll dig into its evolution, the mechanics underneath, not just surface stuff.
So you walk away feeling genuinely clued in.
That's the plan. Hopefully with some insights that, might even surprise you a little.
Okay, all right. Let's dive in then. Let's unpack this thing. If you had to boil it down, like one simple line for someone who asks, what is AI? What would you say?
Yeah, it gets thrown around so much, doesn't it?
Yeah.
Often lost in tech speak or, like you said, sci-fi drama.
Totally.
But really at its heart, the simplest way to put it, based on what we've seen, is this. AI is when machines are designed to, well, mimic human thinking, human learning, problem solving.
Mimic human thinking. Okay. So why does that simple idea matter so much to you listening right now?
Well, because it's not some abstract future thing anymore, is it?
Not at all. It's here, now, woven into everything.
Exactly. Often in ways you don't even notice. Think about it. Every single time Netflix suggests a show, and it's eerily spot on.
Yeah, creepy sometimes.
Uh-huh. Or when you ask Alexa or Google Assistant a complicated question about, say, the weather tomorrow, and it just gets it.
Right?
Or even just unlocking your phone with your Face ID.
Yep. Use it constantly.
That's you interacting with AI.
Wow.
All those instances. And that's where it gets really interesting for your day-to-day life. These aren't simple calculations. They're sophisticated AI systems running behind the scenes.
Making things smoother, more personal.
Precisely. It's this quiet transformation of how we live.
So it's like this digital intelligence working in the background.
Exactly. And to kind of build on that mimicking idea, think of AI almost like a digital baby.
Okay, a digital baby. Explain that.
Well, just like a human baby learns, right? By watching, by trying things, by absorbing tons of information from the world around them. AI learns from data, massive amounts of data.
So give me an example.
Imagine showing a toddler, I don't know, hundreds, thousands of pictures of dogs,
Yeah.
different breeds, sizes, colors, and each time you say, that's a dog,
Right, labeling it.
you're labeling it. Over time, the child's brain starts to pick out the patterns, right?
Mhm.
The common features. What makes a dog a dog? Floppy ears, tail, fur, whatever.
Oh, okay, yeah, it learns the concept.
It learns the concept. Then you showed a picture of a dog breed it's never seen before, maybe some obscure one, and it goes, dog.
It recognizes it.
It recognizes it. AI works on a similar principle, but just on this, unbelievable scale, processing vast, vast amounts of data incredibly quickly.
So the mimicking isn't just about the final output, like the recommendation or unlocking the phone.
No, not at all. It's about the process underneath, the pattern recognition, the ability to predict things, even making decisions based on what it's learned from all that data.
So it's trying to replicate the how of our thinking, not just the what.
In a way, yes. These machines are built to ingest information, find really complex relationships within it, and then apply those learned patterns to new stuff they haven't seen before. A bit like how we adapt to new situations.
And even simple things like Face ID rely on huge amounts of data and complex math.
Oh, absolutely. Immense data sets, incredibly complex algorithms. It just shows how sophisticated even the everyday AI already is. It really sets the stage for what's coming next.
Okay, so if AI is this digital baby learning constantly, what are its tools? What are the methods it uses? It can't just be soaking it all in randomly, right? There must be structure.
Definitely structure. It's not magic. though it can feel like it sometimes. There's a very sophisticated methodology. And the first big concept you really need to grasp, the one you hear about all the time, is machine learning, ML.
Machine learning.
Why?
Heard that one a lot. So what is ML in simple terms?
Okay, so machine learning, ML, it's kind of a shift in how we approach programming computers. Traditionally, you'd tell a computer exactly what to do, right? Step-by-step rules. If this, then that.
Like coding every single possibility.
Precisely. For recognizing a cat, you might try to write code like, a cat has pointy ears and he has whiskers and it probably meows. It gets complicated fast.
Yeah, that sounds impossible to cover everything.
It basically is. So with machine learning, you flip that. Instead of giving it the rules, you give it tons of examples.
Examples like?
Like you feed the computer, say, 50,000 photos, and you tell it these 20,000 photos are cats and these 30,000 are not cats.
Ah, so you provide the answers up front in the data.
Exactly. You provide labeled examples. Then the machine uses statistical algorithms to figure out the patterns for itself. It learns the rules of what makes a cat directly from the data.
So it writes its own rules based on the examples.
That's a great way to put it. It learns from experience, finds those hidden connections, makes predictions, all without you explicitly programming every single step. That's the core idea.
And that's why AI can do things traditional programs struggled with, because it can learn and adapt.
Absolutely. It's not just a faster calculator. It can discover things, adapt to new information, and sometimes, surprise us with what it finds.
Okay, that makes sense. Machine learning is about learning from examples. What comes next? I hear deep learning thrown around too. Is that the same thing?
Good question. It's related, but it's a specific and very powerful subset of machine learning. You could almost think of deep learning as machine learning on steroids.
On steroids. Okay, I like that. Why steroids?
Because it tackles much more complex patterns. Deep learning is actually inspired by the structure of the human brain. It uses something called artificial neural networks.
Neural networks, like digital brain cells.
Sort of, yeah. Imagine layers upon layers of these interconnected digital neurons or nodes. Each layer takes the output from the previous one and processes it further, looking for increasingly complex features.
Layers. How does that work in practice? Like with an image?
Okay, so imagine you feed a deep learning model an image, say a face. The very first layer of the network might just detect really simple things, like basic edges or lines.
Okay, lines and edges.
The next layer takes those lines and might combine them to recognize simple shapes, like curves or corners.
Shapes from lines, got it.
Then, deeper layers combine those shapes into more complex parts, maybe an eye or a nose shape.
Ah, building blocks.
Exactly. And then the final layers assemble all those parts to recognize the entire object in this case, a specific face, or just a face in general. It's this hierarchical process, moving from simple pixels up to abstract concepts.
And that allows it to understand really complex stuff.
Incredibly complex stuff. Natural language, like understanding speech with all its nuances and accents. Recognizing objects in cluttered photos, even if the lighting is weird or the angle is off. That's the power of deep learning.
Wow. Okay, so machine learning is the broad idea. Deep learning is a powerful subset using these neural networks. But how do these systems actually learn? You mentioned examples, but are there different ways they process that information?
Yes, absolutely. When we talk about how machines learn within ML and deep learning, there are generally three main styles or modes of learning. Each one is suited for different types of problems.
Three main styles. Okay, what are they?
First up, probably the most common one, is supervised learning.
Supervised. Like a teacher.
Exactly like a teacher. Think of it as having a teacher with a really detailed answer key. You feed the AI a huge data set where every single piece of input data is already labeled with the correct output.
Like the cat photos example, where we told it this is a cat.
Precisely. Or, say, you give it millions of emails, and each one is labeled spam or not spam. Or historical stock market data labeled with whether the price went up or down the next day.
So the right answer is provided. How does it learn then?
It makes a prediction based on the input, compares its prediction to the correct label you provided, calculates the error, and then adjusts its internal workings, its algorithm, to reduce that error next time. It keeps doing this over and over, getting progressively better.
Fine-tuning itself based on the feedback.
Exactly. Supervised learning is great for things like predicting house prices, identifying fraudulent transactions, diagnosing diseases based on labeled medical images, anywhere you have good historical data with known outcomes.
Okay, supervised learning needs labeled data, like a teacher. What's next?
Next is unsupervised learning. And if supervised is like having a teacher, Unsupervised is more like letting a curious kid loose in a room full of toys with no instructions.
Okay, no teacher, no labels. What does it do then?
It gets a whole bunch of data, but this time, none of it is labeled. No one tells the AI this is a cat or this is spam. Its job is to find patterns, structures, or natural groupings within that data all by itself.
Find its own patterns, like what?
For example, you could give it data on thousands of customers and their purchasing habits. The unsupervised algorithm might automatically cluster those customers into different groups, like budget shoppers, luxury buyers, weekend browsers, even if you never define those categories beforehand.
So it discovers hidden structures in the data.
Exactly. Or it might look at network traffic data and identify unusual patterns that could signal a cyber attack without being explicitly told what an attack looks like. It's really valuable for exploring large data sets where you don't know what you're looking for or where getting labels is just too difficult or expensive.
Discovering the unknown. Okay, that's cool. So supervised with labels, unsupervised without labels. What's the third one?
The third one is quite different and really fascinating. Reinforcement learning.
Reinforcement, like training a pet.
That's the perfect analogy. Think of training a puppy. You tell it to sit. If it sits, you give it a treat or reward. If it chews the furniture, maybe a verbal correction, a punishment of sorts.
Right, rewards and consequences.
Reinforcement learning works exactly like that. You place an AI agent in an environment, maybe a video game, a simulated robot arm, or even a stock trading simulation. The agent then takes actions within that environment.
And gets feedback.
Yes. If an action leads to a good outcome, like scoring points in the game, successfully picking up an object, or making a profitable trade, it receives a positive reward signal. This reinforces that action or sequence of actions.
And bad actions.
Bad actions, or actions that lead to negative outcomes, result in a punishment signal, or just a lack of reward, which discourages those behaviors. The AI learns entirely through this trial and error process, constantly trying things out to figure out the strategy that maximizes its total cumulative reward over time.
So it learns by doing, by experimenting to get the best results.
Precisely. It doesn't need labeled data like supervised learning. It just needs an environment, a goal, maximize reward, and the ability to try things out. This is the technique behind AIs that have mastered incredibly complex games like Go or chess, often discovering strategies humans never even conceived of. It's also crucial for robotics, where robots need to learn how to interact with the physical world.
Wow. Supervised, unsupervised, reinforcement. That's a really clear breakdown. It's amazing how these different approaches let AI tackle such different problems.
It really is. Each learning style unlocks different capabilities, letting that digital baby grow in various specialized ways.
So, okay, we've got a handle on what AI is, the difference between machine learning and deep learning, and these three learning styles. Now let's zoom out again. Where are we actually on this whole AI journey, and where does it seem to be heading? You hear all sorts of things, from mundane apps to, well, world-changing intelligence.
Right. It's a spectrum, definitely. And it's important to understand the different stages or types of AI people talk about.
So where are we now?
Right now, overwhelmingly, we're living in the era of what's called narrow AI, or sometimes ANI, artificial narrow intelligence.
Narrow AI. Okay, the name narrow sounds a bit limiting.
Well, yes and no. Don't let the name fool you. These systems are incredibly powerful, often superhuman, but only within a very specific, narrow domain or task.
Okay, give me an example of narrow but powerful.
Think about Google Maps or Waze. It's absolutely brilliant at analyzing traffic, finding the best routes, estimating arrival times, better than any human could do manually.
For sure, use it every day.
But Google Maps can't write a poem, can it? Or diagnose a medical condition?
Right.
Or even play a game of chess?
No, definitely not. It does one thing really, really well.
Exactly. That's narrow AI. Or think about the AI that plays Go or chess at a world champion level.
Yeah.
It can crush the best human players. But that same AI can't translate languages or recognize faces in photos.
So super smart, but only in its little box.
Precisely. Spotify's recommendation engine is genius at figuring out your music taste, but it can't drive a car. A self-driving car's AI is amazing at navigating roads, but it can't, negotiate a business deal. Each one excels at its highly defined function.
And this narrow AI is what's all around us now. In those examples like Netflix, Alexa, Face ID.
Yes, almost everything you interact with that you'd call AI today is narrow AI. It's the workhorse. It powers spam filters, fraud detection, language translation apps, image recognition, recommendation engines. It's pervasive, often invisible, but highly specialized.
Okay, so that's where we are. What's the next step people talk about, the sort of holy grail?
That would be AGI, artificial general intelligence. This is where things start to feel a bit more sci-fi, though many researchers are actively working towards it.
Artificial general intelligence. What does general mean here?
General means intelligence that isn't narrow or specialized. It refers to an AI that possesses human-level cognitive abilities across a wide range of tasks and domains. Essentially, an AI that can learn, reason, plan, and solve problems with the same breadth and adaptability as a human being.
So not just good at one thing, but good at learning anything, like a person.
That's the concept. Imagine an AI that could, say, learn quantum physics from scratch, then turn around and write a symphony, then have a philosophical debate, then maybe learn to cook a gourmet meal, all with the same underlying intelligence, the ability to transfer knowledge and skills between vastly different areas.
Wow. Okay, that's a huge leap from narrow AI.
Monumental. Narrow AI works within predefined rules or patterns for specific problems. AGI would need things like common sense, intuition, abstract reasoning, maybe even consciousness qualities that are incredibly hard to replicate digitally.
So how close are we to AGI? Is it right around the corner?
That's the million-dollar question, isn't it? Or maybe $1 trillion. Honestly, there's no consensus. Some experts think we might see glimpses of it within decades. Others think it's centuries away, or maybe even impossible in the way we imagine it. The challenges, technical, conceptual, even philosophical, are immense.
So definitely not here yet. Still theoretical.
Very much so. A major focus of research, but still on the horizon.
Okay, narrow AI now, AGI is the goal. Is there anything beyond AGI?
Well, if you really want to venture into the speculative future, there's ASI, artificial superintelligence.
Superintelligence sounds intense.
It is. ASI is defined as an intellect that is vastly smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. Not just smarter than one human, but potentially smarter than all of humanity combined.
Smarter than everyone. Combined, that's hard to even wrap my head around.
Exactly. We're firmly in the realm of science fiction here for now. Think of the really advanced AIs in movies like Jarvis from Iron Man, maybe, on the helpful end. Or, less helpfully, Skynet or Ultron on the more cautionary side. Though researchers are obviously aiming for the former, hopefully.
Hopefully. So what could an ASI theoretically do?
Well, the possibilities are almost unimaginable. An ASI could potentially solve problems that are currently completely intractable for us. Curing all diseases, achieving interstellar travel, solving climate change, maybe even unlocking the fundamental secrets of the universe. Its cognitive capabilities would be beyond our current comprehension.
That sounds both incredible and slightly terrifying.
It does raise profound questions, doesn't it? What would the implications be for society, for humanity's role, for everything if such an intelligence emerged? It's why there's so much discussion now about AI safety and ethics, even when talking about these far future concepts. Ensuring alignment with human values becomes paramount.
Right. Planning ahead, even for the sci-fi scenarios. Okay, that roadmap, narrow, general, super, really helps place things. But let's pull back again to the present, or at least the very near future, like 2025. What's happening right now? What are the hottest trends, the cutting-edge stuff that's actually shaping the next year or two?
Excellent question,
Oh, boy.
because the pace is just phenomenal right now. There are some really exciting developments happening that are moving things forward very quickly. Your sources highlighted 8 key trends that are definitely worth watching.
8 trends for 2025. Okay, let's get into them. What's number 1?
Number 1 is the rise of truly advanced AI agents and assistants. Think beyond the current chatbots like ChatGPT.
Okay, smarter than ChatGPT. How so?
These new agents are designed not just to respond to your prompts, but to plan, reason, and act autonomously on your behalf to achieve goals.
Plan, reason, and act, like mini digital employees.
Kind of. Imagine telling your AI assistant, organize a team lunch for next Tuesday. Instead of just suggesting restaurants, it might check everyone's calendars for availability, find a time that works, research restaurants based on dietary needs and budget, maybe even book the table, send out invites, and handle confirmations. All on its own.
Whoa. That's way beyond just answering questions.
It's a shift from reactive AI to proactive, goal-oriented AI that can manage complex multi-step tasks independently, like mini digital CEOs for specific jobs.
Okay, AI agents taking initiative. That's big. What's trend number 2?
Number 2 is multimodal AI. This is a huge leap in how AI perceives the world.
Multimodal, meaning
AI that can understand and process multiple types of data, voice, image, video, text, simultaneously and integrate that understanding.
So it's not just text in, text out anymore.
Exactly. We're seeing this already with models like OpenAI's GPT-4o or Google's Gemini 2.5. Imagine pointing your phone camera at, say, a broken bike part, asking out loud, what is this piece called and how do I replace it? A multimodal AI could see the part in the video feed, understand your spoken question, identify the specific component, search for replacement instructions, maybe even find a video tutorial, and then explain it back to you, maybe even highlighting the relevant steps in the video.
That's incredibly intuitive, like talking to someone who can see what you're seeing.
Precisely. It mimics human perception much more closely, allowing for richer, more natural interactions and deeper understanding by combining different information streams. It's a game changer for user experience.
Definitely sounds like it. Okay, trend 3. You mentioned these models are often huge. Is that changing?
Yes, and that's trend number 3, tiny yet powerful LLMs. LLM, as you know, stands for Large Language Model, the tech behind things like ChatGPT.
Right, the massive models.
Historically, yes, they needed huge data centers, tons of computing power
Yeah.
running in the cloud. But the trend now is developing smaller, lightweight models that are still surprisingly capable but can run directly on your device.
On my phone or laptop.
Exactly. On your phone, your laptop, maybe even your smart glasses someday. This is huge for a few reasons. First, speed. No need to send data back and forth to the cloud means faster responses.
Okay, faster. What else?
Privacy. If the AI runs locally, your data doesn't necessarily have to leave your device, which is a big plus for sensitive information. And efficiency, less reliance on massive cloud infrastructure.
So, powerful AI, but private and running right here.
That's the goal. Imagine having a really smart AI assistant embedded in your phone that works even when you're offline. It really democratizes access to powerful AI.
That leads perfectly into my next question. If AI is getting easier to run, is it getting easier to create things with, especially for non-coders like me?
Absolutely. And that brings us to trend number 4, which sounds almost like magic. Vibe coding.
Vibe coding, what on earth is that?
It's the idea that you can build software just by talking, using your natural language. No complex code, no technical programming skills needed.
Wait, seriously, just talk to build an app.
That's the vision, and tools are starting to emerge that head in this direction. You could literally describe the app you want. Hey, AI, build me a simple timer app. I want a big start button, a clear display of the countdown, and maybe let me save preset times. And the AI would generate the code, or perhaps even the working application itself.
Okay, my mind is slightly blown. Voice becomes the programming language.
Essentially, yes. It radically lowers the barrier to entry for software development. It could empower millions of people who have great ideas but lack the traditional coding skills to become creators. It's potentially revolutionary for innovation.
Wow. Vibe coding. I'll be watching that one. What's trend number 5?
Trend 5 is closely related to the smaller models we talked about. It's called Edge AI.
Edge AI. Like living on the edge.
Sort of. Edge here refers to the edge of the network, meaning the processing happens directly on the device itself, like your phone, a sensor, a camera, rather than sending data to a centralized cloud server.
So, similar to the tiny LLMs idea, but maybe broader.
Exactly. It's about performing the AI calculations locally. Think about a smart security camera. With Edge AI, the camera itself could analyze the video feed in real time to detect an intruder or a specific event.
Instead of streaming hours of video to the cloud for analysis.
Precisely. This saves massive amounts of bandwidth, increases privacy, the raw video might never leave your premises, and allows for much faster real-time responses because there's no delay sending data back and forth.
Makes sense. Where else is Edge AI useful?
Oh, tons of places. Industrial sensors in factories analyzing equipment health, wearables processing your vital signs instantly on your wrist, autonomous vehicles making split-second decisions based on local sensor data. It makes AI more robust, private, and efficient in the real world.
Okay, Edge AI processing power moving out to the devices. Got it. But as these systems get smarter, doing more complex things on their own, how do we trust them? Especially if we don't understand why they make certain decisions, that whole black box problem.
That is a critical concern, especially as AI moves into high-stakes areas like healthcare or finance. And that brings us directly to trend number 6, explainable AI, XAI.
Explainable AI, trying to open the black box.
That's exactly the goal. Historically, many powerful AI models, particularly deep learning networks, have been opaque. They give you an answer, maybe a diagnosis, a loan decision, a stock prediction, but it's incredibly hard to see the reasoning behind that answer.
Yeah, which makes it hard to trust or fix if it's wrong.
Precisely.
Yeah.
XAI aims to make AI decisions transparent. An XAI system wouldn't just say loan denied. It would ideally be able to explain why, pointing to the specific factors or data points in your application that led to that decision.
So it shows its work, basically.
Kind of like that, yes. In medicine, an XAI system diagnosing a condition might highlight the specific anomalies in the X-ray image that triggered its conclusion. This transparency is vital for building trust, allowing humans to verify the results, debug errors, ensure fairness, and meet regulatory requirements. It's about making AI accountable, not just accurate.
That seems absolutely essential for responsible AI. Okay, 2 trends left. What's number 7? This one sounds intriguing. Living intelligence.
Yes, this one is definitely pushing the boundaries, blurring the lines between biology and technology. Living intelligence refers to merging AI with biological principles or environmental interaction to create systems that are truly adaptive, perhaps even self-organizing or evolving.
Merging AI with biology. Like cyborgs?
Not necessarily cyborgs in the human sense, but think more about principles. Imagine robots that don't just follow pre-programmed instructions, but can actually adapt their physical form or behavior based on their environment, learning and evolving over time like a biological organism might.
Robots that evolve. Seriously.
Or think about swarms of simple AI agents like drones or nanobots that can collectively learn complex behaviors and adapt to changing conditions by interacting with each other and their surroundings, mimicking how a flock of birds or an ant colony operates. It's about creating AI systems that are less programmed and more grown or adapted, interacting dynamically with the real world.
That's fascinating. A very different way of thinking about AI systems. Okay, finally, trend number 8.
And arguably the most important one underpinning all the others, friendly AI ethics.
Friendly AI ethics. Making sure AI doesn't go rogue.
Essentially, yes. As AI gets more powerful and autonomous, ensuring it aligns with human values, morality, and ethical principles is absolutely critical to prevent harmful or unintended consequences. This isn't an afterthought, it's becoming a core part of the development process.
How do you teach ethics to an AI?
It's complex, but researchers are working on various approaches. This includes training AI not just on data about the world, but also on data reflecting ethical norms and principles. Techniques like constitutional AI involve giving the AI a set of explicit rules or principles it must adhere to. It also involves rigorous testing and auditing for bias, fairness, and potential harms before deployment.
So building safety and values in from the start.
Exactly. It's a proactive effort to ensure that the AI we build is not just intelligent, but genuinely beneficial, trustworthy, and serves humanity's best interests. It's about embedding our values into the code, guiding AI's moral compass as it develops.
Wow. AI agents, multimodal understanding, tiny LLMs, vibe coding, edge AI, explainability, living intelligence, and friendly ethics. That's quite a landscape for 2025. These trends really highlight the push towards AI that's more capable, more accessible, more integrated, and hopefully more responsible.
They really do capture the cutting edge right now.
Okay, all these trends, the concepts like machine learning, it's fascinating, but let's make it super concrete again. What are some killer examples of AI that people listening are probably using maybe every single day without even thinking, that's AI?
Well, there are tons. And you're right, the best AI often feels invisible because it just works.
Like those Instagram filters. Or Snapchat lenses, the ones that put dog ears on you, or perfect makeup.
Absolutely textbook example. That's AI, specifically computer vision and often deep learning, working in real time. It has to identify your face, map its features precisely, eyes, nose, mouth contours, and then overlay the digital effect accurately, even as you move. It's incredibly complex processing happening instantly.
Okay, filters are AI. What about something like Google Translate?
Definitely AI. And a great example of natural language processing, or NLP, often powered by large language models now. It's not just looking up words in a dictionary. It has to understand grammar, context, idioms, and reconstruct the meaning in a completely different language structure, sometimes even speaking it out loud quite naturally. Real-time translation between dozens of languages. Pure AI magic.
Right, and in more serious areas like healthcare.
Huge impact there. We mentioned it briefly, but AI analyzing medical images, X-rays, CT scans, MRIs, is becoming increasingly common and effective. AI models trained on vast libraries of images can often spot subtle signs of diseases like cancer, diabetic retinopathy, or heart conditions, sometimes earlier or more accurately than the human eye. It's augmenting doctors, not replacing them, but providing a powerful diagnostic tool.
That's incredible. Potentially life-saving. And the big one everyone talks about, self-driving cars.
The poster child for complex AI systems.
No.
Self-driving cars are a massive integration of different AI techniques.
Yeah.
You've got computer vision analyzing camera feeds, AI interpreting data from radar and LiDAR sensors, sensor fusion combining all that input, prediction algorithms guessing what other cars or pedestrians will do, and reinforcement learning often used to train the driving policies. It's a symphony of AI trying to navigate the incredibly complex real world. Still a work in progress, as we know.
Still almost driving themselves, yeah.
Exactly. But the AI powering them is incredibly sophisticated.
What about creativity? Can AI be creative? I hear about AI making music or art.
Yes, and this is a rapidly growing area using generative AI. Tools like Suno can compose original music in various styles based on a text prompt. Platforms like DALL-E, Midjourney, or Stable Diffusion can generate stunning, unique images or artwork just from your textual description.
So you just type a cat riding a bicycle on the moon in the style of Van Gogh.
And it generates that image. It's learned the patterns of language, concepts, and artistic styles from billions of examples, and it can now synthesize novel creations based on your ideas. It really challenges our traditional notions of creativity.
It really does. Filters, translation, medical diagnosis, self-driving tech, even art and music. It's clear AI isn't just one thing. It's this collection of techniques showing up everywhere.
That's the key takeaway. It's diverse, integrated, often working quietly behind the scenes, making things faster, smarter, safer, or just more fun. It's already deeply embedded in the fabric of our modern lives.
Okay, so with AI being everywhere and doing so much, it's natural that myths and misunderstandings pop up. You hear some pretty wild claims. Let's bust a few of the biggest myths floating around.
Good idea. There's definitely a lot of misinformation out there.
What's the first big one? The one that probably causes the most fear? AI is going to take everyone's jobs.
Yes, the robot apocalypse job scenario.
Yeah.
It's pervasive. But the reality, based on historical trends in current analysis, is much more nuanced.
So not everyone gets replaced.
No. It's more accurate to say AI will replace tasks within jobs rather than eliminating entire human roles wholesale, particularly repetitive, predictable, data-heavy tasks.
Okay, automating parts of the job, not the whole person.
Exactly. Think about it. AI might automate report generation, data analysis, or customer service chatbots for basic queries. This frees up the human worker to focus on more complex, strategic, creative, or interpersonal aspects of their role, things AI struggles with.
Like creativity, emotional intelligence, complex problem solving.
Precisely. Collaboration with colleagues, ethical judgment, nuanced communication, strategic planning, these uniquely human skills become more valuable, not less, in an AI-driven world. The future is far more likely to be one of collaboration humans working with AI tools to be more productive and focus on higher value work. Job roles will evolve. New jobs centered around managing and working with AI will emerge. But mass unemployment caused solely by AI is not the most likely scenario. It's about adaptation and reskilling.
Okay, so AI replaces tasks, not people. That's a much more optimistic view. Myth number 2. AI is always right. It's objective and unbiased because it's just math.
Oh, that's a dangerous one. Really dangerous.
Yeah.
Because it's fundamentally untrue.
Why? Isn't it just algorithms and data?
Yes, but where does the data come from? AI learns from the data it's fed, and if that data reflects existing human biases, societal prejudices, or historical inequities, well, AI will learn those biases too.
Garbage in, garbage out. G.I. Joe.
Exactly the principle. If you train a hiring algorithm on data from a company that historically hired mostly men for technical roles, the AI might learn to associate male candidates with success and unfairly screen out qualified female candidates, even if gender wasn't an explicit input.
So it can inherit and even amplify human biases.
Absolutely. AI doesn't have inherent common sense or ethical understanding. It just identifies patterns in the data. If the patterns are biased, the outcomes will be biased. This is why data quality, diversity in data sets, and rigorous testing for fairness are so incredibly important. Assuming AI is automatically objective is a major pitfall. Human oversight and critical evaluation are essential.
Right. Critical to remember AI is a reflection of its training data. Okay, final big myth. AI can think and feel just like us. Is ChatGPT secretly conscious?
Haha, the consciousness question? No, not yet. And maybe never in the way we understand human consciousness and motion.
But it sounds so convincing sometimes. It can write poetry, have conversations.
It's incredibly sophisticated mimicry, based on predicting the next most likely word or pixel given a vast context learned from trillions of examples of human text and images. It can generate responses that seem empathetic or creative because it's learned the patterns of human expression associated with those concepts.
So it's pattern matching, not actual feeling.
Exactly. It doesn't feel sadness when it writes a sad poem. It doesn't understand the concept of love when it discusses philosophy. It's executing incredibly complex algorithms to produce statistically probable outputs that match the input prompt. There's no genuine self-awareness, subjective experience, or emotional state as far as we know.
So AGI, that human-level general intelligence, is still far off, and true consciousness is even further.
Correct. We need to be careful not to anthropomorphize these systems too much based on their impressive outputs. They are powerful tools for simulating certain aspects of intelligence, but they aren't sentient beings in the human sense. That distinction is crucial.
Okay, myths busted. AI replaces tasks, not people. It can be biased if its data is biased, and it doesn't think or feel like humans yet.
Aha.
That clears up a lot. Now, moving beyond the myths and the tech itself, what's happening on the global stage? We touched on AGI labs and chip factories. Are there other big news items showing how central AI is becoming?
Oh, absolutely. The global activity is intense. It really underscores AI's strategic importance.
Like Meta going all in on AGI research.
Exactly. That move by Meta, launching a dedicated superintelligence lab aiming directly for AGI, wasn't just a press release. It signals a massive long-term strategic bet by one of the world's biggest tech companies. They see AGI not just as a scientific challenge, but as potentially the next fundamental computing platform, and they want to be at the forefront. It shows the scale of ambition and resources being poured into this.
And Europe's 20 billion investment in chip factories.
That's a huge geopolitical move. Chips, the specialized processors needed for AI, are the foundational hardware. Right now, manufacturing is concentrated in a few places. Europe's investment is a clear statement about wanting technological sovereignty, the ability to produce these critical components domestically, reducing reliance on other regions and ensuring they have the infrastructure for their own AI ambitions. It's about economic security and strategic autonomy in the digital age.
So control the chips, control the AI futures to some extent.
That's certainly part of the thinking.
Yeah.
And related to that, you see NVIDIA constantly pushing the envelope. Their announcement of the next generation Rubin chips is another example.
NVIDIA, the company making most of the AI chips currently, right?
Yes, they have a dominant position in the market for the GPUs, essential for training large AI models. Each new generation of their chips enables bigger, more complex AI models to be trained faster and more efficiently. Hardware advances like this are a fundamental driver of AI progress. Without faster, more powerful chips, the software side would hit a wall. So NVIDIA's roadmap is a key indicator of where the whole field can go next.
Hardware enabling software. Makes sense. And what about how we interact with AI? You mentioned Google's AI search mode.
Right, Google rolling out its AI overviews and transforming search into more of a conversation is a fundamental shift in user experience. It's moving beyond just typing keywords and getting a list of links.
Towards actually talking with the search engine.
Exactly. Using multimodal AI to understand more complex queries, maybe even incorporating images or voice, and synthesizing answers directly rather than just pointing you to web pages. It aims to make finding information more intuitive, more conversational, more like interacting with an expert assistant than a simple index. It shows how AI is changing even our most basic digital interactions.
It really feels like every angle, research goals, infrastructure, hardware, user experience, is being reshaped by AI right now.
It truly is. The scale of investment and strategic focus across continents and industries is unprecedented. It's clear AI is seen as the defining technology of our era.
Okay, it's powerful, it's global, it's advancing incredibly fast, but we need to be clear-eyed. Every powerful technology has downsides, risks, a potential dark side we need to watch out for. What are the biggest concerns we need to keep front of mind with AI?
That's absolutely crucial. Ignoring the challenges would be incredibly naive. And there are significant ones.
Like what? What's top of the list?
One major and growing concern is energy usage. We touched on it with data centers. Training the largest AI models requires staggering amounts of electricity.
Staggering how?
Some estimates suggest that certain AI training runs can consume as much energy as hundreds of homes use in a year, or that the entire AI sector's footprint could rival that of a small country soon. As AI scales, this thirst for power poses a serious sustainability challenge. We need breakthroughs in energy-efficient hardware and algorithms and a shift to renewable energy sources for data centers. Otherwise, AI's environmental costs could become immense.
Wow, the carbon footprint of AI. That's not something you hear about every day. What else?
The issue of bias, which we discussed in the myth section, isn't just a myth to debunk. It's a persistent and serious real-world harm.
Because biased AI can lead to unfair decisions in real life.
Exactly. In loan applications, hiring, criminal justice, access to healthcare. If the AI systems used in these areas are biased due to their training data or algorithms, they can perpetuate and even worsen existing inequalities, discriminating against certain groups systematically and often invisibly. Ensuring fairness, equity, and transparency in AI systems isn't just a technical challenge, it's an ethical imperative. It requires constant vigilance, diverse development teams, and robust auditing.
Okay, energy use bias. What about jobs? We busted the replace everyone myth, but there will be disruption, right?
Yes, job disruption is a real factor even if it's not total replacement. Automation driven by AI will displace workers in certain sectors, particularly those performing routine, manual, or cognitive tasks that can be easily codified.
So some people will lose their jobs or need to find different work.
That's the likely reality. While new jobs would be created, roles managing AI, designing AI systems, roles demanding creativity and emotional intelligence, there's likely to be a transition period that could be difficult for many individuals and communities. This requires proactive measures, investment in retraining and education programs, social safety nets, and strategies to ensure the economic benefits of AI are shared broadly, not just concentrated among a few. We need to manage the transition thoughtfully.
A societal challenge, not just a technological one. And what about truth itself? You hear about deep fakes.
That leads to the fourth major concern: misinformation and manipulation. The rise of generative AI makes it frighteningly easy to create highly realistic fake text, images, audio, and video deepfakes at scale.
Stuff that looks completely real but isn't.
Exactly. AI-generated fake news articles, fabricated videos of politicians saying things they never said, realistic but fake social media profiles spreading propaganda. This technology can be weaponized to sow discord, manipulate public opinion, commit fraud, or harass individuals. It erodes trust in information, institutions, and even our own senses.
That sounds incredibly dangerous for democracy and society.
It is. Developing robust detection methods for AI-generated content is crucial, but it's an arms race. We also urgently need clear regulations, ethical guidelines for developers, and media literacy education for the public to navigate this increasingly blurry line between real and fake. It's a profound threat that requires a multifaceted response.
Energy, bias, job disruption, misinformation, those are some serious challenges. It really underscores that developing AI isn't just about making it smarter, it's about making it responsible, safe, and beneficial.
Absolutely. These aren't just technical problems. They are deep societal and ethical issues that demand careful consideration and proactive governance right now.
Okay, so given this incredible potential, the fast pace, the exciting trends, but also these significant challenges,
Huh.
what can the average person listening right now actually do? How can you ride this AI wave instead of just being swept away by it? How can you participate?
That's the key question, isn't it? Moving from passive consumer to active participant. And the good news is there are very accessible ways to get involved and stay informed.
Like what? What's step one?
Step one, honestly, play with the tools. Seriously, get your hands dirty.
Just try them out.
Yes, sign up for ChatGPT, Google Gemini, Claude. Try image generators like Midjourney or Dall-E. Experiment with AI video tools like Runway or Pika Labs. Create some music with Suno. Use AI features and tools you already have, like maybe Descript for audio editing.
Why is playing so important?
Because there's no substitute for direct experience to understand what these tools can actually do, what their strengths are, where they fall short, and how they feel to interact with. It demystifies the technology incredibly quickly and makes it less intimidating. It moves it from abstract concept to tangible tool.
Okay, play with the tools. Makes sense. What else? Do I need to go back to school for a computer science degree?
Definitely not necessary for a good understanding. Step two is to learn AI for free using accessible resources. There are fantastic online courses designed for everyone, regardless of technical background.
Like what? Any recommendations?
The Elements of AI course from the University of Helsinki is often recommended. It's free, high quality, and designed for a broad audience to explain the basics conceptually. Platforms like Coursera, ADX, Khan Academy, even many YouTube channels offer great introductory content on AI, machine learning, and related topics without requiring you to be a math whiz.
So accessible education is out there.
Plenty of it. Just dedicating a little time can give you a solid foundation.
Okay, play, learn. What's step three? AI changes so fast.
Exactly. So step three is to stay updated. Make it a habit to follow AI news and development.
Where's the best place to do that?
LinkedIn is actually great for following AI researchers, companies, and commentators. YouTube has many channels explaining new AI papers or tools. Following reputable tech news sites or specific AI-focused newsletters can help you keep pace. Even X, formerly Twitter, if curated carefully, can be a source for breaking news and discussions. The key is continuous learning because the field evolves week by week.
Stay curious, keep learning. Got it. And step 4, you mentioned vibe coding and easier creation.
Right. Step 4 is build something. And thanks to AI and no-code, low-code tools, this is more possible than ever, even if you can't program in the traditional sense.
Build without coding. How?
Explore no-code platforms that integrate AI features. Use tools that leverage that vibe coding concept, allowing you to create apps, websites, bots, or automate tasks using natural language prompts or simple visual interfaces. You could build a custom chatbot for your hobby club, generate AI art for a presentation, automate parts of your workflow. The barrier to creation is lower than ever. Try bringing one of your own ideas to life using these tools.
Play, learn, stay updated, and build. That sounds like a concrete action plan.
It really empowers you to engage proactively. And it raises that final question for you, the listener. How can you take these tools, this knowledge, and apply it? How can you leverage AI to enhance your own work, your creativity, your learning, your future? The potential is there for everyone to tap into.
What an incredible journey we've packed in today. We started with the basics, what AI actually is, that idea of mimicking human intelligence. We explored how it learns supervised, unsupervised reinforcement learning. We looked at the big picture, where we are with narrow AI and the future horizons of AGI and ASI.
Then we dove into those really hot 2025 trends, the proactive agents, multimodal understanding, tiny models running on your phone, even vibe coding and AI ethics.
Exactly. We busted some common myths, saw how AI is making waves globally with huge investments in new products, but also faced the crucial challenges, the dark side, like energy use, bias, and misinformation. And we saw concrete examples of AI you're likely using every single day.
From Instagram filters to potentially life-saving medical tools.
Right. And hopefully that action plan gives you some clear steps to take next. Because ultimately, as we've kind of circled back to a few times, AI isn't just about the technology itself, it's really about you. It's about how it shapes your habits, fuels your creativity, impacts your work, and defines your future.
Understanding is the key to empowerment.
It really is. So the big takeaway shouldn't be fear. It should be understanding. Learn about it. Use the tools. Think critically about it. And maybe even help shape where it goes. Because the story unfolding isn't AI versus humans, it's going to be AI with humans. So the real question we leave you with is, what will you create with it?
Yeah, and if you connect that to the really big picture, maybe the most important lesson here is that even though AI is incredibly powerful, maybe the most powerful technology we've ever created, its direction, its ultimate impact, that's still very much being written. It's in our collective hands. Your understanding, your engagement, your voice in the conversation, it all matters in steering this towards a future we actually want. So stay curious, keep learning, keep asking the hard questions.